going to start to write the equation of sine and cosine graphs. From the graph, we want to come up with the equation. First thing I want to point out is that these two equations are slightly different, but they provide the same graph. So far, we've been working with equations that look like the first one. And in order to get the phase shift, we set the argument equal to 0 pi. And solve for x. And now we know that our phase shift is pi. If instead we use an argument that has the coefficient factored out, we can automatically see the phase shift here would be to the right pi. That's going to be an easier way for us to format the equations that we write. And in order to write an equation, we first decide if it's a sine or a cosine, or sometimes we're told which to use. We need to find the amplitude. That's your leading coefficient. The vertical shift is the number added or subtracted at the end. And together, the period and phase shift go into the argument. But we're going to start to keep our argument with the b coefficient factored out. And inside the parentheses, x or theta minus the phase shift. In order to get that b coefficient, we will always use 2 pi or 360 and divide by the period that we can tell from the graph. So here we are asked to write the equation of a sine function. First thing I want to do is to identify one phase of a sine function. Some of our answers will vary depending on the phase we select. So it's important that you highlight the phase that you plan to use. One phase. If I were to use this phase, I'll start to identify the characteristics. The midline or vertical shift is positive 2. The amplitude is 6 minus 2, or 4. This particular phase is reflected, but the phase shift is 0 degrees. The domain of one phase starts at 0 degrees and ends at 360. The period of one phase is 360 minus 0. And the range is minimum to maximum. I could put that together as an equation. Y equals negative, because it's reflected, amplitude of sine. My b coefficient, I left a space. I will use theta since it's degrees, minus 0 degrees. Oops, let me back up. I don't need to write in theta minus 0 degrees. I'll just put theta. And at the end of the argument, the vertical shift. Now I still need that b value. To get that b value, I will take 360 and divide by the period of the function. That's equal to 1. So my equation, I should have done that first. is -4, y equals -4 sine of theta plus 2. Had I picked a different phase, maybe you looked at this graph and you picked this phase. That's perfectly fine. Some of our answers will be different. Some of our characteristics are different. It'll adjust our equation just slightly. The vertical shift is still 2. The amplitude is still 4. This time, this phase is not reflecting. And the phase shift is 180 degrees. One domain, the domain of the phase highlighted in green, goes from 180 degrees to 540 degrees. However, when I subtract those values to get the period, I still get 360. And the range does not change. This equation would then be y equals positive for sine. B value is still 1. Theta minus the phase shift. And a plus 2. So the differences will be with the phase shift and whether or not it's reflected. For this example, we are asked to write the equation of a cosine function. So I will want to highlight one phase of a cosine function. I could select this phase. If I select this phase, the phase shift is pi over 6. And the domain of this phase is pi over 6 to 7 pi over 6. 7 pi over 6 minus pi over 6 is 6 pi over 6, and that is pi. So we've got a period of pi. And this cosine phase is not reflected over the x-axis. The vertical shift, or midline, would be at 5. The amplitude is 7 minus 5, which is 2. And the range of the graph would go from 3 to 7, minimum to maximum. To find my b value, I would always take 2 pi and divide by the period. That's the coefficient I'll put in my equation for this phase. And that equation would be y equals not reflected, so do not put a negative, amplitude of 2 cosine, b value is 2, parentheses, x minus the phase shift, use x for radians, plus the vertical shift. And just for the sake of practice, what if you had selected this as your phase? There would be no problem with that. Some of the characteristics and parts of the equation would be exactly the same. The vertical shift is the same. The range is the same. The amplitude is the same. This one is reflected and has a phase shift to the left. That makes our domain slightly different from negative pi over 3 to 2 pi over 3. But if you subtract those, 2 pi over 3 minus a negative pi over 3 gives you 3 pi over 3, or pi. That should not change. And the adjustments we would see to that equation are that we have a reflection and a different phase shift. X minus a negative pi over 3, yet the vertical shift is the same. Now, you only have to write one equation. I just want you to see that there are variations in the equations that we might write.